So in this video we are going to see how to solve a problem based on the formulas which we did in the class today. So we can see that we have got two formulas here for resistance, okay, for resistance related to length and area of cross section. If you remember, we did this in the class, as well as we have got the formula for resistance related to voltage and current. So let's read this question number 2. It says a conducting cable of radius 4 centimeter. So we'll write the data. R is equal to 4. Radius is represented by R. R is equal to 4 centimeter. Because it's in centimeter, we have to convert it into meter. So 4 divided by 100, that is 0.04 meter. Okay, now let's see what else is given. It is made up of an ohmic material, and it says that the resistivity of the material, sorry, let's just choose the highlighter. Yeah, the resistivity of the material is 2 into 10 power negative 6. So we will check where is the resistivity in the formula. If you see this rho which we had in this formula, it's called as resistivity, and as we discussed, it depends on the material of the object. So resistivity, the unit is ohm meter. Check here also, the unit is being written as ohm meter. Okay, so we'll write the data. We'll write rho is equal to 2 multiplied by 10 power negative 6 ohm meter. Then let's see what's the next thing which they are asking. Calculate the resistance. They are asking for resistance. So we have to calculate the resistance. So R is being asked for. R is question mark. Then if they give 12 meter segment of the cable. So 12 meter segment of the cable. This means they are talking about the length. Length is equal to 12 meter. So how do we solve this? We have been provided with, if we check, we know what is the resistivity, we know what's the length, and we know what's the radius. And this, from this radius, we can actually calculate the area of cross section, which is this one, area of cross section. So if you cut a wire, the area of cross section will look like a circle. So area of cross section for a circle, or area of a circle, will be given by pi r square. This is the area of a circle. Why are we taking a circle? Because when we look at a wire, okay, let's say this is our wire. The area of cross section, look at this, looks like a circle. Yeah, it is a circle. So we'll be using A as pi r square. Now we'll just quickly calculate this. Pi is given as 3, so we can write 3 multiplied by R is given, we got R here, so 0.04 square. Okay, so area of cross section, we can write 3 multiplied 0.04, we can multiply and get the answer. It will be 0.0016. Okay, so A comes out to be 0.0048. Now we will use the formula. We have to get the resistance, so we have to use this formula for resistance, because we have got resistivity, we have got length, we have got area of cross section. So we have to just substitute. So let's use that formula. R equal to rho L over A. Rho is 2 multiplied by 10 to the power negative 6. L is, let's check what was L. L is 12. So 12 divided by area of cross section is 0.0048. Now if you calculate this, you will get the answer as 5 multiplied by 10 to the power of negative 3, and the unit will be ohm, because we are calculating resistance. Now you need to complete this answer, whatever we are solving in the video, you have to complete it in your class kick. Okay, now let's look at the second part. It's asking for the current, so it's asking for I, and it's giving you potential difference across is 6 into 10 to the power negative 2. So it's giving you V is 6.00 into 10 to the power negative 2 volts. So we have to check which formula to use. It's asking for I, so obviously the formula will be this one because it has I. So we'll use that. Let's write down that R equal to V over I. We have to rearrange the formula because we want to get I. So I will be equal to V over R. V is 6.00 into 10 to the power negative 2, and R we calculated in the previous part, which is 5 into 10 to the power negative 3, this one. Okay, so we will use that in the second part. 5.00 into 10 to the power negative 3. When we calculate this current, it comes out to be 12 ampere. So in the same question, we can see that we are using both the formulas to get the answer. Okay.